Do another briefing. I'm just going to, this briefing I'm going to be talking about the upcoming chances of snow in the Pacific Northwest, as I talked a little bit about last video. Um, we still have that chance for snow in places like Seattle and Portland, although it is a very tricky forecast. The models are two main computer models that meteorologists like to look at, the GFS and the European, are still um, diverging quite a bit on what they believe the outcome will be in terms of the placement of the cold air and how much snow will fall in these areas. My cat is awake, so you might hear her in the background. Now, I'm gonna put this is a computer model projection, by the way. I always like to give these disclaimers that when we're looking at computer model guidance, be it from the American GFS model or the European model or the Canadian model that I like to look at sometimes, or other models, it's just a projection based on the conditions of the atmosphere today as we best understand them. So the computer models are taking data from satellite, radar, weather station observations, balloon soundings, data from upper levels of the atmosphere. They're putting that all together, and they're using their algorithms and their different data sets and such to project what might happen in the atmosphere the next several days based on that data that we have today. But the atmosphere is a fluid. The atmosphere is always changing, so any change in the initial conditions that occur with each run of these models, that happens every 6 hours or so. Particularly the forecast past 5 days can change drastically from run to run, because you have different initial conditions with each run, and even just small little differences in those conditions can mean a different projection for the future. So, with that explained, I'm going to go through what the GFS is projecting, and then I'll compare it to the Euro. The GFS pretty consistently for the last few days has shown a transition to snow overnight in Seattle, for instance, from Friday night into Saturday morning. So I'll put this here. I'll put the cursor right over where Seattle is here. You can see 10 a.m. Friday, it's still rain. And then this is 1 a.m. Saturday, 4 a.m. Saturday, 7 a.m. Saturday, that's all snow. See, the GFS overnight, it's transitioning Seattle into that snow. Now, why is it doing that? And that's doing the same thing roughly for Portland. This computer model believes there's enough cold air leaking out at this point, down from the north, that this would be possible. You can see these blue lines here, and these represent the thickness of the atmosphere. And the lower that thickness, there's usually more cold air coming down from the north. And we like to look at that 522 line, what it's doing. And you can see that's way down here. That's cold air leaking out. That, in theory, would be cold enough to snow, but this is just one run of one model. We're still about 3 days out. It's hard to tell if this is exactly what's going to happen. And that's a close call, because I mean, there's just a lot at play here, but you really need the timing to be right. You really need enough of this cold air to get down at the same time as there's the moisture coming up off the Pacific here. You need those two to clash, but you need enough cold air here. You don't want this moisture to bring too much warm air, because that's going to ruin the chances for snow. Now, show you the temperature. Okay, I ended up managing to change that, of course. Let's look at the temperature at 2,500 feet. -3 Celsius, that's around 24 Fahrenheit, roughly. Now, at the 2,500 foot level, it's certainly cold enough for this precipitation to be falling in snow. And watch that cold air, as I showed, overnight, Friday into Saturday, it starts plunging in, but how much of that is going to get down? How much of this bitter cold Arctic air up here is going to leak out into the lower elevations? That's what's going to play a big role in terms of how much snow or not there will be in Seattle and Portland. But if you look at the surface temperature projections on this model, for early Saturday morning, it's not quite that cold yet. Looking at 5 a.m. Saturday, it's 35 degrees. I think that's maybe a rain-snow mix. Certainly not really, don't really expect much to stick on the ground by that point, when it's still that mild. Look at the other model we look at a lot, the European model, which has been having some trouble, but looks like it did load for us here. Look at that, the European has 38 at the surface at 4 a.m. So the European would be even less bullish on snow. If you look at the precipitation parameter, like I was looking at earlier, see now, okay, here we go. Yeah, so the European still has rain up and down the valley, Portland, Seattle here. Very different solution here. Let's look at the, I mean, it's not vastly different, but it's pretty different. There's a lot more warm air making its way into the air mass, particularly at the lower levels here. Let me just show you what I mean. So that 522 line, remember how on the GFS it's down here? Just taking that to show you as an example. On the European, look at it, it's up here. That clearly means warmer air is making its way still into Portland and Seattle. Look at that. So the European has a lot more warm air advection still going on here as compared to the GFS. And the European, the resolution on the European is a little better, and a lot of times the European, it just has different data sets and such. A lot of people say the European tends to do a little better with the forecast, and I think the resolution is really important. When you have a lower resolution model like the GFS, it's not as good at picking up at the terrain features and such, and local microclimates, and maybe some areas near the water it's not quite cold enough to snow, and it might be cold enough to snow a few miles inland. GFS is just going to kind of paint that all as snow because it's a lower resolution. European might do a better job of picking up the pockets of warmer air that might still be all rain or rain-snow mix. But you can really tell here when you just draw these from the thickness lines here that the air is a bit warmer. There is a little more warm air advection on the European. And you want to look at if I want to show you I showed you the surface temperatures. Let's look at the 2,500 foot temperatures here. So as I showed the GFS 4 a.m. on Saturday, it's got maybe -3 Celsius at the 2,500 foot level. We want to see at least that temperature, probably -3 or lower to get snow. We want to see -3 or lower at the 2,500 foot level. What is the European projecting? It's not even showing that. Okay. European model, 4 a.m. on Friday. Look at that. 2,500 foot, 2 Celsius. It's actually above freezing. See, that's a lot warmer. Compare that to the GFS. Will the GFS? Yes. Will it show here? Okay, this is going... I'm sorry. There's an issue here. Yeah, this model has been very wacky with giving proper data. It's not really letting me see the Saturday time frame. But you get the idea. There's a lot more warm air. And it's just going to be tricky to see how and where this sets up. If I do a previous run, I might have a little more luck showing that. Yeah, okay. Previous run is working okay. So, but look at that. Look at how aggressive the GFS is with this cold air compared to the European. So the European has the colder air, that -3 line that we want to see at 2,500 feet. It's up here. And GFS is way further south and east. Look at that. GFS has a lot more cold air already in place. When we have that moisture, we have that moisture come up from the Pacific. Look at that. It's clashing with the cold air already in place, which is good enough for snow. The European's not buying that. European has it still pretty mild up here. And when this moisture comes in, if it's still pretty mild, it's going to be rain or rain-snow mix, most likely. It's not going to accumulate very much. And this is interesting. This is only 2 to 3 days out, and there's still quite a bit of disagreement here. Where the European, it still wants some warm air, and this isn't even like a surface temperature issue. I mean, up aloft, it seems like it's still a bit warm for you to have ideal snow. Now, I want to explain a little better what needs to really happen for that cold air to really lock in place. You want to have that Arctic air mass that's supposed to come in to the Pacific Northwest. You want to have that really leaking out, the cold air from that leaking out. I'm going to show you a different map. It's going to give you a better representation. This is what's going on with temperature anomaly and wind speeds at wind direction and speed at 5,000 feet roughly. And so this European model here, as we go in through the day on Saturday, it's still not bringing a lot of that cold, frigid Arctic air down. See, a lot of this is locked up further north. We really need this to leak out. We need this to leak out into lower elevations in order to get good snow. We need this to push further down. So that's not quite happening yet, at least on the early morning of the first time frame. You can see that's not really happening. The coldest air is still way far north. Still way down here. It's way up here. It's coming down, but it's still far north. Now, if I switch this to the GFS, see, it's still far, but look at what happens as we get into the third. Look at this early on the third. It starts to finally leak. Look at that. Look at this. This is an easterly wind. This is coming down. This is finally leaking in. It's exactly what we need. By the third, the GFS has a significant leak of cold air in here, which would facilitate snow. So we go back here, and bam. We have that linking up with the moisture. Perfect, because we have this spinning area of low pressure at the surface off the coast. And that's bringing plenty of moisture, and that is linking up with that cold air I was showing that's coming down from the north. You see these blue thickness lines all stacked up together here, that means there's really cold air that's pushing down from Canada. I'll go ahead and show that here. See these thickness lines here? That means this cold air is leaking in. It's exactly what we want for the snow potential. So better chances later on, especially with the GFS. See, the first and then the next round that comes in around the second into the third, that's more promising in terms of enough cold air being in place. If you put the European on, let's go to the 0Z run, because the other run was giving me a hard time. See, there's that first round on the first, it's just too warm on the European. But then here's that on the third. The European doesn't bring as much moisture, but it brings a little bit. Then it's definitely cold enough to snow, but there's just like, it's a matter now of how much moisture will there actually be in order for snow to occur. It becomes an issue of moisture rather than an issue of cold. Because at this point, the cold is definitely there. And you can see this rain-snow line across parts of Oregon and Idaho here. You can see where there's heavy snow for some of the interior areas, but it's just how much it will be at the coast and how much warm air is going to intrude. It's going to be a battle of the warm subtropical air and the cold Arctic air here. And that's going to really determine how much snow or not we can expect to see. Just to finish out the video, I'll look at the ensembles, which is basically taking 50 different members for the GFS and the European GFS. 50 different members tweaked for different conditions and initial conditions, and then an average of all of that, all of those members. And by the late night of the 3rd, you're looking at the European ensemble mean calling maybe 2 or 3 inches for Seattle, maybe about the same for Portland. GFS ensemble maybe a little more, maybe 3 to 5 inches for these areas. So it's gonna depend. It's really going to depend on that cold air, how much of it we get, how much of the moisture comes in at the same time. But it's looking like there's a solid shot for at least an inch or of snow or so. Now, if I put the probabilities here for snow, 1 inch or more, by the let's look at the 11 p.m. on the 3rd time frame. I mean, most areas that are not on the water are seeing at least 50% chance. You go the further inland you go, even just a little inland here, you're looking at 60 to 70% chance of at least an inch of snow. But you see how the probabilities are a lot lower when you get right on the water here, because it's just it could be too mild. There could be too much mild oceanic air coming in through here, particularly if that wind flow is still more onshore at the surface by the water. It's really going to depend. But if you go into the 5th, as I was showing, because that second round is going to be cold enough on both models. Go into the 5th and 6th, look at that. Looking at 80 to 100% chance that we'll see at least an inch of snow widespread in these areas. But the exact timing is really going to depend on how much cold air is available, how much moisture is coming in. Is the moisture bringing in too much warm air? But anyways, I know this is very technical, but I hope this kind of helps give a little more insight on snow in the Pacific Northwest, how it's forecasted, the factors that play in, and such. So I hope you were able to get something out of this. I hope you enjoyed it. Thank you for watching, and I'll see you next time.